go ahead and open your books to page 81, and I also want you to take out your vocab organizer. We are starting activity 6, which is all about interpreting graphs. So we're going to look at lesson 6.1, which says relate the domain and range of a function to its graph, and then identify and interpret key features of graphs. So today we are going to do a lot of vocab. Okay, so bear with me. Roller coasters can be scary but fun to ride. Below is the graph of the heights reached by the cars of the Thunderball roller coaster over its first 1,250 feet of the track. The graph displays a function because each input value has one and only one output value. You can see this visually by using the vertical line test. Study this graph to determine the domain and range. So remember our vertical line test. We talked about that a little bit in activity 5, where if you draw vertical lines through this function, it only crosses or touches the function at one spot or one point. So that would be a function. Okay. Independent and dependent variables. Those are new vocab terms. So if I'm looking at domain, remember domain is our x values, our input values. It's also our independent variable. Okay, so in this case, it's the distance along the track, which is measured in feet. The domain values are graphed along the horizontal or your x-axis. The domain of the function above can be written in set notation. Remember, set notation means we're using our fancy brackets. Okay, so if I'm looking along my x-axis, horizontally from left to right, I start here at 0, and I go all the way, and I end at 1250. Okay, so we're going to ignore this part when we're writing domain and range. I'm going to cut that out. And we're just going to use fancy brackets. And notice we have a conjunction right here in our fancy brackets. Remember that from before, a conjunction, it's a compound inequality. So this is telling me that all my x values are between 0 and 1250. So greater than 0 and less than 1250. And you can see that on your graph above. So for domain, it's your x, it's your input, it's your independent variable, and we look horizontally left to right on your x-axis. So our range now is the opposite. The range is our dependent variable, which is our output or our y-axis. Okay, so we're going to look up and down vertically. So if I go up to my graph here, we're going to look low to high. So my graph starts down here at 10, and it goes all the way up to right here, which is 110. So those are my range values right here. There should be a fancy bracket, and we start at 10, and we're going all the way up to 110. So y is in between those two things, so notice that this is written as a conjunction again. Okay? If you're looking at the math terms in the My Notes section of your book, it says an independent variable is the variable for which input values are substituted. Independent input values. Your dependent variable is determined by the input. by the independent variable. Those are our outputs. Okay, so the independent is x, the dependent is y. And if you were in class, I would give you a little sheet that looks like this. But since you're not, find a scrap piece of paper and you can write this down. And remember, the more notes or the better notes that you take, you can use them to help you on a quiz or a test. All right. X is always our independent variable. Remember, X is the input. Y is always your dependent variable. And remember, Y is the output. So this goes along with what we learned in activity 5. So changing the independent variable causes change in the dependent variable. So your dependent variable depends on the independent variable. The dependent variable y depends on the independent variable. Some people like to think about that as your y-axis depends on the x-axis in order to stand up vertically. Okay, go ahead and turn over to page 82. Look at all those vocab terms. It says the graph above shows data that are continuous. The points in the graph are connected. Okay, so continuous, connected. Indicating that the domain and range are a set of real numbers with no breaks in between. So continuous is connected with no breaks. A graph of discrete data consists of individual points that are not connected by a line or a curve. So discrete are individual points, no line or curve. So we are going to add these two to our vocab organizer. Remember, it looks like this. We already have a few spots filled out, but you should have a lot of empty spaces. So let's write continuous. If you don't have a vocab organizer, you can just write this down on a piece of paper. So the definition, the points in a graph are connected. Continuous, connected. So what that means is that we have no breaks in our graph. I can draw the whole graph without picking up my pen or my pencil. So let's draw an x and y axis, an x and y axis. So here's my graph. It's a U shape. It's got two endpoints. This is connected because it's continuous. There's a curve. I drew that U shape without picking up my pencil. Okay, same thing. This is also continuous. All the points are connected by a curve. There's no breaks. Here are some non-examples. Point, 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 point. And there's a lot of different individual dots, individual points. There's breaks in this graph, so it's not continuous, so this is not a non-example. Same thing if I have this, it's called a piecewise function. There are breaks in the graph, but this is not connected, it's not continuous, so it doesn't work. Okay, the next one we had was discrete. So remember, discrete would be individual points not connected by a line or curve. So think about this connected, discrete, disconnected. Students in the past have said the word dots instead of points. Disconnected. So if my graph looks like this is discrete because there's individual points. There's no line, there's no curve. If my graph looks like that, think about there's so many dots, so many points along this line that are connected by a curve, so that does not work. This is a continuous graph, not discrete. Okay? So if I look at these two graphs, which one is discrete and which one is continuous? The first one is discrete because this graph shows individual points or individual dots. It's disconnected. There's no line or curve. And then this graph right here is our continuous graph because there's a line, there's a curve. Even if there were not arrows here, even if there were endpoints, this is still considered continuous because it's connected. Right? If I put points here, these points are connected by this curve. So this is continuous. Okay? Right. Another vocab term. The y-intercept of a function is the point at which the graph of the function intersects the y-axis. So y-intercept, y-axis. it's also the point at which x equals 0. You guessed it, we're going to add it to our vocab organizer. Y-intercept is something that you're going to use a lot in second trimester as well. So the y-intercept, the point, oopsies, there we go, the point at which the graph intersects the y-axis. This occurs when x equals 0. So how we write it, it's always 0, comma, whatever that y value is. So I'm going to draw an x and y axis. I am going to sketch in a line. Okay, if we're looking at this graph, remember it's where your line touches or crosses your y-axis, and your y-axis is your vertical axis, so up and down. So if I'm looking at this, my y-intercept is this point right here. This is my y-intercept, which in this case occurs at 0, 1. We went up one spot, one space. Or if you think about slope-intercept form, y equals mx plus b. This b value right here is always your y-intercept. So if it said plus 5, instead of b here, 5 would be my y-intercept. If it says minus 2, negative 2 would be my y-intercept. Always write it as an ordered pair. This is not a y-intercept because x is not 0, it's 2. This is also not a y-intercept because x is not 0. Y is 0, so this actually would be an x-intercept. So if we go and look at these graphs right here, okay, your y-intercept, I kind of want you to look and practice writing down what you think your y-intercept is. 0, comma, where does it cross your y-axis that I just highlighted? Same thing here. Where does it cross? Where does it cross? So 0, if I count, it's 1, 2, 3. So 0, 3 is my y-intercept. This graph right here, it crosses at 0, 1. And this graph crosses right here, which is 0, 0. Okay, that's your y-intercepts. So if we were looking at a roller coaster graph, hopefully you still have that page open in front of you. Okay, here's my y-axis right here. This is the point right here where I touch or cross that y-axis, so that's my y-intercept. And if I was to write it, my y-intercept would be 0, 10. 0, 10. Okay, stick with me. We have a few more vocab terms, and then you'll be done for the day. Hopefully your hand's not cramping yet. A relative maximum is the greatest f of x value, which is the greatest y value, in a limited open domain interval. A relative minimum is the lowest value of y for values in a limited open domain interval. What that means, because they must occur within open intervals of the domain, relative maximums and relative minimums cannot be endpoints. Okay, the math tip box says endpoints are not included. Endpoints are not included. So I'll show you examples in a minute, but let's add relative min and relative max to our vocab. Relative maximum it is the greatest or the biggest or the largest or the highest y value in an open interval. Open interval means cannot be endpoints. So I have to look like throughout my graph. Cannot be at the beginning or the end. So what we do is we look for a hill. A hill in your graph. So here's my x-axis, here's my y-axis. Just going to draw on a graph. I kind of see a hill. So we're going to say it's right here. This would be my relative max. And I'm going to say it occurs at 4. Just made up the number. And then let's draw another graph. Here's my x and my y. And let's say it looks like this. This does not work for a relative maximum because this high point occurs at the end point, so it doesn't work. So this is not a relative maximum. Okay, relative minimum. This would be the lowest y value in an open interval. Again, remember it can't be an endpoint or your endpoints are not included. And when I look at my graph, I look for a valley or a U shape. So let's say I have a graph that looks like this. See the valley? See the U shape? So right down here, this point would be our relative minimum. And let's just say that it occurs at -2. And here's my other graph. This is not an example right here because this is an end point. Although it's the lowest, it doesn't work because it's an end point. Okay. Do we see any relative minimums and maximums on this graph? So let's look for relative maximum. Where do you see like a hill or a high point? Perfect, right here. Good. This is a relative max. And I see a valley or a U shape right here, so this would be a relative minimum. And this would also be a relative minimum. So we can have more than one valley or low point. So relative min, relative max cannot be endpoints. They have to occur throughout or within your graph. Now, think about the word absolute, right? If I said the absolute maximum of a function is the greatest value no matter what. Okay? The absolute minimum is the lowest y value no matter what. Unlike relative maximums and relative minimums, absolute max and absolute min may correspond to the endpoints. So if I said, who's the oldest person in the room? That's the absolute maximum age. Or who's the youngest person in the room? That's the absolute minimum. It doesn't matter if they're male or female. Okay, I just want the oldest person and the youngest person no matter where it occurs. The oldest, the youngest, the highest, the lowest. So let's look at this roller coaster graph. We're not going to put that on our vocab organizer. Hopefully you can just remember it. It's the highest and the lowest no matter where it occurs. So remember, we already said that this was our y-intercept. Okay. What's the absolute maximum here? The highest point no matter what. And you probably want to draw this on your graph. The absolute maximum. Look all the way to the top. It's right here. This is my, absolute maximum. No matter where it occurs, that's the highest point. What is an absolute minimum? Absolute minimum, the lowest point. It's right here. It's at 10, and it's also right here. It's at 10. Okay, it just occurs twice because our roller coaster starts and ends at the same spot. So the highest point and the lowest point, no matter where they occur. Now let's talk about relative minimums and relative maximums. They can't be endpoints. Okay, so relative minimum, do you see a valley or a low point? It's right here at 30. So a relative minimum. Do you see a hill? Right here. So this is a relative maximum. And it occurs, if I draw my line over, it occurs at like 90. And I actually have one more relative max. And it's right here. This is also a relative max because it's not an endpoint. Okay. So we covered a lot of vocab terms. This is where we're going to stop for today. Good work. Thanks for sticking with me.